John Paffett, who's going to tell us about KISPE, of which I know nothing. So I'll shut up and let him explain it. Thanks. Over to you, John.
Thank you. In fact, I'm not going to tell you all about KISPE. I'm going to tell you about the open source satellite program. But for those that don't know me, and I think that's most of you actually, my name is John Paffett. I've been in the space industry for getting on for about 30 years or so now. Was fortunate enough to be at college one day when Martin Sweeting walked in and talked about launching AMSAT-UK and how he was going to go about setting out to do space differently. And at that point I thought, wow, that sounds really fascinating. You know what, I'm going to go to Surrey and do my degree and play with spacecraft. So I went to Surrey and had nothing to do with spacecraft. So that was at a point where the sort of academic side wasn't as well linked up with what we were doing on the research side, and thankfully that's beginning to change quite a bit anyway. So I was with Surrey for about 23, 24 years, I guess. Engineer by background, started off on the RF side and digital side, moving into systems engineering. So you're right about system engineering, it's a bit of a, definitely a shortage. Then we sort of moved away all the way through the organisation until I left about 3 years ago and set up a group called KISPE. And I'll come back to a little bit about KISPE in a second. So I thought today what I'd do is talk about this initiative that we've kicked off called the Open Source Satellite Project. And it's really good actually to be following on from Barnaby, because Barnaby set out some of those interesting challenges. If we think about space and we think about the utility and application of space, it's really in its infancy. That might sound like a silly thing to say, but really it is. I mean, communications is probably the most commercial application that we have today, and geostationary communications leads the rest of the market probably by about 30 years, and other areas are beginning to commercialise, but we really are just beginning to see the commercialisation of space. And one of the challenges with small sats, for example, is, say, looking forwards to how we may be able to stimulate future applications and services in the future. And Barnaby mentioned about the role that small satellites can have, and I definitely subscribe to that. They can almost become the pathfinders to enable us to prove new applications and services. In fact, when I first started with Surrey, it was, 30 of us? And if you'd gone to Euroconsult, which is one of these market surveys, and looked up the market for small satellites, there was no market. You know, they're really good at predicting what the market is for established markets. They're not so good at stimulating what the market is for new services. So today, I'm going to talk about the Open Source Satellite Project, why we're doing it, the vision for what we're trying to achieve, talk about the user perspectives and what the goal of this project is, and really is to sort of call for arms, because what we're really keen to do is stimulate a community and get more people involved in this program, really to take space from where it is today and move it up a notch. And so that's really where we're coming from. When I left Surrey, I thought, why did I join in the first place? It's because I believed in what Martin was trying to do, which was to make space more accessible. And that job's not done. You know, there's a lot of really interesting things going on, but there's still a long way to go. And it's through things that are going on in communities like this and other communities around the world that are helping to stimulate that growth of what we can do with small spacecraft. So a little bit about KISPE, and this is not a sales pitch, but we're basically a systems engineering company. So when I started with Surrey, say there was about 30 of us, there was no market, so we're out cultivating the market for small satellite solutions. There were no suppliers, so we had to do everything ourselves. Fast forward 30 years, and we're surrounded by lots of really bright people with great ideas. The bit that's missing is the glue. So the systems engineering, the program implementation piece. So when we left Surrey, we set up a group of system engineers basically to help work with customers, turning their ideas into realities. A little bit corny, but that's what we do. One of the things we've retained, though, is this ethos where not to be afraid to do something if you can't find it elsewhere. And that's really what became the genesis of this project. So what we found when you sort of step back is we had traditional space. And I won't call it big satellites or small satellites, because actually some of the very early spacecraft were quite small. They were just quite expensive. And space was the preserve of a small number of spacefaring nations. So getting into space was difficult. And then along came groups like Surrey, Orbital were another group, who looked at it and said, hold on a minute, there's a different way of doing space. And in this instance, applying things like commercial off-the-shelf components and bringing a significant cost reduction in the price of making spacecraft. So really pleased to have been part of that movement in helping to radically reduce the price of space. Fast forward a bit, and Georgie and the team out in MIT came up with this idea of the CubeSats. And the CubeSats did an absolutely amazing job at reducing the barrier costs. So coming up with the lowest cost spacecraft to enable people to put spacecraft into orbit. And so what you started to see is a couple of interesting tension points that were trying to bring the price down and change the entry level costs. But if I map those, they sort of follow on a line. And what we're now seeing is we're seeing groups starting to try to come down in price. So again, the likes of the Surreys of the world, and less so now with Orbital, because it's now ATK. A number of other companies are coming along sort of trying to come down in price. The CubeSats are coming up in size. One of the issues there is basically they're still CubeSats, just in a bigger box. And if you look at it, although there's those sort of pressures, they're still on that same line. And there was a talk earlier about sort of needing businessmen, and so people in suits and people with beards. One of the things that we've found working with a lot of our customers is there's a lot of people out there with great ideas for businesses or great ideas for new applications and services. And one of the challenges today is they cannot close their business case. So some of them want a 50 kilo class spacecraft, but they want to pay the price of a 5 or 6 kilo CubeSat, for example. And so there's a real dilemma there. And I often hear people say, but I only need a spacecraft to last for a year. I question that. I think that's actually a lie. I think it's more a case of I can only afford a spacecraft that lasts for a year. In reality, what we really need to do is get off that line. So we need to find a way of having higher performance spacecraft at a fraction of the price. And I know, Barnaby mentioned earlier that ESA's looking at trying to do things in that domain as well. And that's exactly where we came from. So we said, okay, there's a need to step off that line and do something differently. So we need to not be following the norm, but just doing something different. Now, I mentioned as a company, we're a systems engineering house, so we're not tied to any given manufacturer. So this caused me a little bit of a dilemma, because on the one hand, there's this market need for a platform that's at the price point of a CubeSat, but at the performance of a microsatellite. But on the other hand, I don't want to be a satellite manufacturer. So I thought, well, how do I reconcile both of those issues? And the other element was when I stepped back, I thought, well, this industry, although it's in its infancy, it has some very old behaviours. So they mentioned sort of traditional industry, IP, it's mine, I'm going to keep hold of this and I'm not going to share this. Or very predatory behaviour. So a small company comes along and down comes a big company and squishes it. So we thought, okay, can we just try to address that market need by doing it differently? And stepping back and looking not at the space industry. I mean, I didn't call the company, I didn't use the word space in the company initially for a very simple reason, that sometimes we're a little bit too space is special. There are some subtleties in the space domain, but a lot of the problems that we face are actually common across many different industries. So we stepped back and said, okay, can we learn things from other industries and apply them to space? And so we said, okay, let's generate a next generation microsatellite, but let's do it completely open source. And I'm not just talking the software, I'm talking the entire design of that platform. So can we go about stimulating a fully open source 25 to 250 kilo class microsatellite platform, get the community involved, grow the community, and make that platform available to all. And then use that as a basis to grow a greater capability. And why am I trying to do that? Basically because the one thing, I mentioned about space in its infancy, the one thing I think we all have to get used to is change is a constant. And so if people have a predefined way of doing things, or you're a business that does things in a particular way, if you carry on doing it that way, you ultimately are going to die, because you've got to be constantly changing and evolving yourselves. So we were looking at this to say, okay, can we try to really stimulate the market to do things differently? In fact, I was talking to Roland, one of the guys who was working with Geordie in the early days of the CubeSat, and when they did that first CubeSat, they basically said, well, we know it's only going to last a year, but that's okay, because this is the first time we've ever flown this. So Roland's view was basically that that wasn't acceptable. That was just going to be a stepping stone to what they were going to do next. What he wasn't expecting was they did the first one, and then all of a sudden the community went, well, that's great, that's acceptable. And so a 1 year sort of CubeSat became completely acceptable. And he was saying, well, no, we should be pushing for a higher place, pushing for more capability, more performance. So we thought, okay, how can we stimulate the community, and how can we develop that capability? Now, being very clear, I say platform. So I'm not talking about the full satellite. We're not straying into export control issues of giving away high-resolution Earth observation spacecraft. What we're trying to do is develop and build those foundational building blocks, get a performant microsatellite platform that people they can then take and build upon, and then use that for their own missions and applications and services. So really just trying to raise that bar and stimulate the markets. Because there's a lot of really great stuff being going on across the community in a number of different areas, so that's what we're trying to achieve. And our vision really, say, is to stimulate the utility and application of space. My little caveat to that is I'd say in a responsible and sustainable way. There's lots of challenges as we start to use spacecraft for a range of different things. It's interesting to hear Barnaby talk about putting CubeSats around the moon. That's great, but how are we actually going to be able to see them? Not the moon, he said geo, but how are you going to be able to see them in geostationary orbit, for example? So there's a number of challenges that have to be overcome. So we're looking at how can we apply different rules, different processes, and really reduce the price point of a satellite platform and make that accessible. And our goal, our pledge, for want of a better term, is to make that material available. So we've looked around. There's a number of interesting open source programs. There's a sort of growing number, which is excellent. In fact, I'm off to Athens this afternoon because there's a open source CubeSat workshop there, and I think there's 200 odd attendees, which is excellent. One of the things that we've seen, though, is making sure that that information is there, memorialized, as it were. Spire, I don't know if any of you realise, but Spire's genesis was in an open source program called the Arduino Sat. Try Googling that and finding the information. Sort of it's evaporated. So how do we make that information available and make sure that it's accessible to all? And that's really where we're pushing. And again, we're not just talking about the software, we're talking about the bills of materials, the parts list, the schematics. And so the goal is that we'll be feeding out the information between now and when we launch. And within a year of the launch of the first one, all of that design information will be available. So that then gives us a building point that people can then build upon. And for those that are working with us in parallel, then they're accessing that information earlier, as it were. So that's our goal, that's our pledge. Key thing from my perspective, though, is to really understand what the stakeholders want. One of the real challenges being in this industry full of very bright people, bright engineers, we have this sort of habit of looking at things from a technology perspective. And really stepping back and saying, okay, so it's not just about the technology. What does the customer need this to do? What's the application and service? What's the need this is trying to address? So we've done a lot of work around what are the potential customers for such a platform, ranging from commercial entities that are trying to close a new business case to entities that are trying to prove a technology. So there's a range of different customers or users. How's this thing going to be operated? There's no point putting a low-cost spacecraft up in orbit if it's then going to cost a fortune to operate. So looking at it very much from an operator perspective as well. And that's maybe where, both on the RF side and some of the operations side, this community may be able to help us out with some of those elements as well. Looking at it from a payload perspective. So one of the things we're trying to do is bring a bit of engineering discipline into the design. So clearly delineating between what is the satellite platform and what is the payload. If I think back to my years with Surrey, we must have developed 7 different versions of an onboard computer. Well, if I step back and look at it from a customer perspective, so what? The onboard computer, it just holds the spacecraft and controls the spacecraft. It's not a mission-defining piece. Yes, we would have probably had to design a couple because of obsolescence and things, but a smarter thing would have been just to have left the onboard computer alone and focused our effort on the mission-defining things like the payloads, like the applications and the services. So trying to bring a bit more discipline, trying not to use the satellite platform to do payload things, and by doing that, enabling us to radically reduce the price point of the satellite platform. And then the other part, which I think is actually, to be honest, the harder piece, is stimulating and growing the community. So if we design an open source spacecraft and don't tell anybody about it and don't have anybody involved, then we've failed. And so one of our core goals really is to help grow and stimulate that community. And when I say community, I mean the wider ecosystem. So not just the people that are involved in the satellite platform, but also people that are involved in other aspects around that. So it sort of becomes a go-to repository and a way out to the other communities. I know Chris, for example, has been doing loads of work at the university, and some of that stuff's interested to the wider community. So can we use this as a funnel to get that information out to people as well? We started working with a group in the US recently who have come up with this modelling and simulation environment, and they enable people to actually come up with a digital twin of a spacecraft to start checking stuff out earlier. And so we've been bringing them into the community because it's a way of people flushing out how a spacecraft may work without having to put a huge amount of investment into the design efforts initially. So really sort of growing that community is part of the goal. Now, where does this fit in? If I think about the market segmentation and some of the recent trends. So here's where I was, say, with companies such as Surrey. So we'd taken a different approach to small satellite engineering, and that enabled us to deal with a range of spacecraft. And these numbers are all sort of notional, but anywhere between sort of 50 kilos, 300 kilos. Really trying to drive that price performance point down. Really some interesting challenges around scaling and bringing the sizes down even further. Then along came the CubeSats. Again, I've changed my view a little bit on CubeSats. When if you'd gone back 10 years, I would have questioned their utility and application. At the end of the day, you can't break the laws of physics. And it's all about aperture at the end of the day. So whether that's antenna or it's solar panels or it's optics, you can't change that, unless any of you have, in which case I'd love to know. So there are some interesting challenges. Now, I say I've definitely changed my mind. What I've seen with the CubeSat domain is some really, really good engineering and creativity that's come about because of the constraints that have been put on that volume. And in fact, some of the payloads that are now being developed for CubeSats, if you just take them and put them in a bigger box and maybe change them slightly, you can do some really interesting things. So it's really been good from an innovation perspective. So I think that's good. As with all these things, though, there's good and bad. So we have customers that come in and say, we want a 3U CubeSat. You go, no, you don't. You have an application or a service you want to do, of which the 3U CubeSat could be the answer. But you don't set off saying, I want to buy a 3U CubeSat. Basically, you want something that's cheap and does your job, whatever size that is. And so that's sort of where we're looking at the moment. The other trend, and you've probably heard about this in the press with things like OneWeb, apparently that's the answer to everything now. We don't need small satellites anymore because OneWeb's going to solve everything for everybody. Don't get me wrong, I'm being a little bit facetious. OneWeb and systems like OneWeb have been really good because they've made us sort of look in the mirror and go, looking a bit fat. Are we really being as lean as we can be? Are we really taking innovative approaches to solving some of these problems? And systems like, say, OneWeb and Starlink and things have certainly made people think about how to do things differently. Where the argument sort of starts to fall over is people are now saying that if you have a production line that is building 1,000 spacecraft, then it's really cheap to just add yours to that mix. Well, if that was true, there would only ever be one car production line and one aircraft manufacturing line. The reality is all of these spacecraft are very niche, very unique, even systems. Even when we think about 1,000 spacecraft, from a space perspective, well, that's a lot of spacecraft. From a commercial electronics perspective, that's nothing. We were looking at actually producing the onboard computer for OneWeb before it was OneWeb when Greg was in Google. And I got all excited about how we could have a pick-and-place machine and we could do the manufacture ourselves until I really sat down and went, I'm an idiot. We would have built all of the onboard computers in 2 weeks. So what's the point of investing in that production line? Because for 50 weeks of the year, it wouldn't have been used. So certainly, but there are things you can do. So if you want a 150 kilo spacecraft for doing communications with a payload that looks a lot like a OneWeb spacecraft, then buying another OneWeb platform off the production line is a cost-effective route. If, however, you've got a slightly different payload or you only need a 1 kilo payload, then that's clearly not the solution. So for us, we're looking at each of these pieces and going, well, there's pros and cons in all of those. And so part of the genesis or part of the rationale for what we wanted to do here was how can we make the one-offs cheaper? How can we have a lower cost platform that can be made in a handful that enable some of these business cases to close? And so how can we leverage a number of those different aspects? And so looking at, can we have a platform that's in that 25 to 250 kilo class? Now that's quite a broad spectrum, but we deliberately have picked that because it makes us think about some of the scalability issues. We want a platform ultimately in the long term for what I'd call benign and harsh environments, so LEO, MEO, GEO and beyond. I don't know how many of you subscribe to Elon Musk's or Jeff Bezos's view about humanity being a multi-planetary society. So I certainly do. I mean, if we're going to avoid extinction, I think we need to be beyond this planet. However, if we're going to go to other planets, the one thing we're going to need is communication lines. And so we're going to need communication systems that enable us to communicate between here and the moon and here and Mars and between the moon and Mars. So how do we do that, and how do we do that in a cost-effective way? And we started looking at one of the business cases for a lunar communication system. Yes, I could do a demonstration mission for putting up a comms relay, fine, that's quotes easy. Well, it's not, there's a few challenges, but how do you put up a system that's commercially viable and will last for a number of years in what's quite a harsh environment? So really looking for a platform that's suitable for both benign and harsh environments. That's both versatile and scalable, and it's accessible. So that's really where we're sort of coming from, and what we're trying to do with the Open Source Satellite Initiative is address that need and really just stimulate change, stimulate different ways of thinking. In terms of what's this thing need to do, now this project is very much in its infancy. It's part of the reason why I was really pleased to get the invite and start to talk to the community and start to get people involved, because we want people involved to help shape the destiny of this journey as well. So what are the capabilities that this platform needs to have? So I mentioned already, we want this thing to be fully open source. We want an ability for people to take this and adapt it and modify it if they need to, so that they're not reinventing the wheel, so that they can start with a known baseline and then build upon that. We want something that's high performance, but at the price point of a CubeSat. Now, how do we do that? Getting rid of the labour. So basically 70% of a microsatellite platform's labour costs. And so if you're going out and you're building a number of boxes and then you're integrating all those boxes together and you have to test all those boxes, that's a lot of labour. So if you can start to take out the labour from that program, then you can start to reduce the cost of the program. So that's really where we're looking at as well. In terms of the sort of size and capabilities, so the platform itself is parasitic. Is that the right word? If you're a user or you have a use or an application or a service, you really don't care about the launch or the platform. It just holds your payload up there. Sometimes, though, as an engineering community, we get all excited about the launch and we get all excited about the satellite platform, and you go, but they're really not the mission-defining pieces. The mission-defining piece is what it does. And And so actually, if you've got a satellite platform that's 100 kilos, and 90% of that's a satellite platform and 10% of that's payload capability, you've probably got the ratio wrong. And so really we're sort of trying to focus down and go, actually, we want a 70% payload carrying capability on the platform. We want it to be scalable so that we are able to do payloads, you know, the machine-to-machine or the small AIS type payloads are relatively low power in size, or low power in their requirements. On the other hand, we're seeing a growing interest in things like synthetic aperture radar, much more higher power type payloads that require more power to be generated by the bus. So a number of those things. Lifetime is a key point for us. As I was saying earlier, when people talk about a 1-year lifetime, I mean, how many of you buy a mobile phone or a laptop and say, I only need this to last for a year? Nobody. You buy it and you want it to last as long as it needs to last until you buy the next one. You know, the lifetime of the computer or the mobile phone should not be the mission-defining element. I'm trying to get to the point where as well, low sort of rapid schedule, open up for a range of different launch scenarios and interoperability with ground stations, etc. So really a spectrum of capabilities. And again, what we're really after is feedback from the community on the sorts of things that people are looking for. We already know, for example, on the work that we've been doing with some of the CubeSat programs, you know, it's not, when I say it's just about aperture, that's a bit unfair. One of the other issues, though, we have with a small size, it's quite a difficult form factor. It's quite unforgiving, as it were, from an EMC, from an RF perspective. So going to a slightly larger box gives us some freedom there as well. So there's some of the capabilities of what we're looking to address. In terms of the timeline that we're on at the moment, so we're looking at a launch in 2022, so we're working towards that at the moment. We're very much in the early concept architecture phase, so we're actually embracing things like model-based systems engineering as an interesting approach. I think that's a tool suite that's in its infancy as well, but moving away from paper-based reviews to reviewing a single model where we have a sort of single truth of what this spacecraft design is. So we're starting off very much with a top-level architecture and drilling down that architecture before we then jump across to the implementation. So thinking about what functions does this spacecraft have to have, not where are those functions implemented. So really starting to think differently about a spacecraft and how that spacecraft may be implemented. Ideally getting to a point where most of the core elements of those spacecraft are in a single box or blob. And those are the pieces that don't change on a mission-by-mission basis, and it's the things that are sat on the outside of that you change and customise. You know, a great example is a wheel. If you think about what's in a wheel, you've got elements of that wheel that do not change on a mission-by-mission basis, like the control electronics, the algorithms. The bit that changes is the size of the mechanical piece and the drive electronics for the wheel. For the motor, rather. So can we move some of those functionality and put those functions in different parts of the spacecraft? Interested in doing a similar thing on the IF stage as well. How much of that can we have in one place and bring into one module and make that work? So we're working towards that, really with the goal of, say, having a first launch at the beginning of 2022 and then starting feeding out the information in the meantime, but then making that full repository of information available to the wider community at that point. I'm not, we certainly have some challenges. And one thing I'm very wary of is we won't get there in one go. And so we're already looking at that roadmap and saying, okay, ideally, we would like a satellite platform that's well suited for benign and harsh environments. So when I mean benign, I mean low Earth orbit. And when I mean harsh, I mean the radiation type environment, so MEO, GEO and beyond. We won't get there on step one. So we see a sort of succession of steps, as it were, where we get to what I'd call the 70% solution. So in this first mission, we'll have a much higher level of integration than we have in spacecraft today, which is great. But I think the next step for me is we take that and we shrink that down into a chipset, and that gives us even more level of integration, but it also gives us the solution that we need for the harsh environments. So that will be a successive step. So we're being pragmatic in the way that we implement the program, because the key thing for us is making steps on that journey to get something done, to get that information out into the community, to give something that other people that can then build upon, if that makes sense. And so with that, very much focused on making sure we have a robust architecture. Systems engineering, and it was interesting to hear somebody mention that earlier. It's one of those jobs that if you do it well, nobody knows you've ever done it, which makes it difficult to then sell it to people because they go, we don't need you. That's probably the hardest bit with our business model, is when we go in to speak to some of our customers, they say, no, we know this stuff. And you go, no, you don't. Especially, well, I'm not going to tell you who it was, but they were telling me how they were going to have a satellite to dwell over the UK. And you go, this is in LEO, by the way. And you say there's things called physics and orbits, and that's not going to happen. So it's sort of trying to educate them and take that approach. So the robustness is a key element, and we're seeing that with a number of the smaller spacecraft where they're making savings is in the wrong places. A lot of people think that if you just go and buy lots of subsystems and equipment and bolt them together, it works. If it does work, you're really lucky. There's a lot of issues on the integration and the interfaces, and that's where the systems piece is quite key. So looking at use of commercial off-the-shelf parts and tools and the model-based system engineering approach, feeding that across, looking at higher levels of integration, and then how may we go forwards in the future to really shrink it even further. Trying to make sure as well as we continue on that journey that we're regularly communicating. And this is in its infancy, and we really welcome people to be involved and contribute and participate in the program. We're trying to make sure that we can put information out to the community. We've started off just publishing a few articles and a few blogs. I think they're probably on the cadence of about once every couple of weeks at the moment. We certainly want to increase that up, increase that rate, and get more participation from people writing articles of things that of interest, not just to the satellite platform development, but the wider community. From that, we'll also start to make some of the information available. And for example, one of the projects that Chris and I is looking to do through a program called Sprint is doing some radiation testing on the process that we're looking to use on this spacecraft. Well, once we've done the radiation testing for that, we will make that information available so that people that want to use that information can use that information. They don't have to start again. So again, making some of that information available to all. So you'll see this is a placeholder at the moment that will start to flush out as we start to put more information on there. Anita, one of the team, reliably informs me I will be doing more webinars. I think the term is kicking and screaming, but really trying to make some of that information more accessible and available to all. But what we're really interested in is getting people involved, both on the sort of community side in terms of supporters. We've got a couple of people who have nothing to do with the company now, who are supporting us on things like the OBC on part selection, for example. And one guy, Marcel, who's looking as well at what processes we might be able to use in the future. So a number of people that are sort of trying to get involved. On both the in-kind investment side, in-kind side, we're also talking to potential sponsors for the future as well, looking at how we can bring the funding in to complete the rest of the program as well. So that's very much work in progress. But if people are interested in getting involved, just either come see me or look at the links on here later. So that's really where I was going to leave it. So that's sort of giving you a snapshot of what we're up to and what we're about. And if anybody's got any questions.
John, thank you very much.
We've got time for
Any questions? Okay, I'll go around with the microphone as well as I can.
Great talk. I started off thinking you were either a complete nutter or 1 in 100 million. I'm veering towards the 1 in 100 million. Particularly pleased to see on the final slide, or the last but one, in your roadmap, you have interplanetary missions at the bottom there after the LEO and everything else. So 20 years ago, I was giving a talk in various venues called "A Mission to Mars?" ? Every university should have one. Thank you. You're on your way.
Yeah, thank you.
Okay. Another question?
How are you going to... this is Dave Johnson, G4DP. So, how are you going to flight-proof your stuff? Is it going to... You're going to have one flight?
So,
I'm sorry, let me finish. But it's interesting that you want to make this a reference platform. We've been fortunate from the FunCube point of view in that we did space proofing on FunCube 1. We've now flown 5 with the same platform.
yeah.
And I wish you the same. I wish you the same as well.
Yeah, with us, I mean, although we're starting from scratch, let's start from scratch with experience of 50 plus satellite programs, and actually, and that's why the good example of the radiation testing that we're looking to do with the University of Surrey. So we know that we want a processor. We really want to make sure that that element is robust enough for what we want for the future. So in that instance, we're going to do some testing. I think what we'll see is, although I showed 3 phases, that's not going to be reality. What I do want to avoid, though, and I'll be clear about that, is I want to make sure that we get to a position of stability, because continually finessing the platform is a little bit of a waste of effort. And actually getting to, and what do I mean by that is once the onboard computer is, the onboard computer element, for example, is finalised and working, other than obsolescence, there's no point going back and reinventing the onboard computer. You know, it's much better getting people thinking about the applications and the services and the payloads, because those are the things that really take it forwards. That doesn't mean that we won't be looking at constantly sort of evolving the platform, but that will be evolving the platform to do the things it can't currently do. And that's why I sort of showed on the roadmap, thinking about benign environments initially, then moving to harsh environments in the future. Because trying to do both of those at the same step is a step too far.
First of all, thank you very much for this really informative presentation. My name is Sascha Toll from Germany, the Space Operations Facility of the University of Applied Science of Aachen. One question that really interests me is, so that's a cool idea, but that's not the really new idea, and it's also not the only existing one. There are also platforms like, for example, LibreCube.
Yep.
There are platforms from AMSAT, which is kind of commercial. So I have 2 questions. The first question is, what would be the main difference between LibreCube and you? What is your uniqueness? And the second question is, at which degree are you really open source? Because many are pretending they are open source, but they are only open source maybe in one part, and for the other one not really. So that's the 2 questions.
That's a valid question, and that's why I mentioned about the pledge, as it were. So in answer to your question, this is not an either or. In fact, we embrace, and that's what I was saying about going off to Athens this evening, because those guys will be there, because there's a number of different developments going on. The difference, I guess, is a number of the open source initiatives so far. Well, some started off in the software domain. Others are moving into things like the open source CubeSat. We're seeing some really good work that's going on in that domain. Where we were providing a step is to go, well, that's great, but actually what we want is a microsatellite platform. So the one bit that is different today is that it's a microsatellite platform. Now, if somebody comes along in parallel with us and says, well, we want to take on that and run with that, great. So long as it does exactly as you've just said, that it does become truly open source. Because a number of the initiatives we've seen start off, or whether they start off, but they're not truly open source. You know, and if they say they're open source, can you actually get access to the information to build upon that information? Yes, and that's where we're very conscious, and that's what we're trying to avoid, because that doesn't address what we're after, which is really to say raise that bar. But actually, what does success look like? What success looks like is the rest of the community is starting to go, well, hold on a minute, my CubeSat design needs to be a bit more robust. It needs to have more longevity. It needs to be more reliable. And so they take a look at their existing designs and say, well, you know what, this isn't good enough, and I need to start to improve the capability of that. And so actually, success looks like a raising of the bar, and that's the other element to this as well. But to your point about the openness, we're trying to make sure that the full design is open source. And that is why we've delineated it at platform level, so that we don't run into export issues on the platform. That's why I'm doing it here in the UK, because I do not want to do this in the US. And I'm being very careful when we start soliciting inputs from people that we don't inadvertently find ourselves on the wrong side of that barrier as well.
Thank you. Any other questions or comments? Okay, John, we'll let you off the hook. Thank you very
Thank
much
you.
indeed for an intriguing
Thanks.
presentation. We've got a short break now. We're due to start again at 1:45 in 20 minutes, when Chris Bridges will be giving us an update on his activities at University of Surrey.